Good morning, this is Ryan at Midnight Solar, and today I want to show you how to use the local app to program your classic light, or standard classic for that matter, to use the WBjr and how to interpret all of the state of charge settings and the information you get from the WBjr. I'm going to assume that the WBjr is already wired to the classic. I'm also going to assume that you already have the local application on your computer and are able to connect to your classic. If either one of these are problems, please see the videos that correlate to that, or look at the manual for the WBjr or give us a shout. So here's what you would see. Let me minimize this. This is how the local app would come up when you first start it. So the controller we're going to be working on is Solar HV right here. So we're going to scroll over and we're going to click on View. Now this is what we call the maximized view, or the dashboard. And as you'll notice, we're in Absorb, and over here is the WBjr info. Now this will be here if you've programmed it, so we'll assume it's not programmed yet, and let's run through that. So we're going to click on Configure, the Config button, and one thing we have to do is we have to enter the classic serial number right here. You don't have to enter the CL or any of the zeros, but we do need to enter the serial number right here, and then we need to submit that serial number the first time to unlock the classic so we can write to it. Now once it's all done, we're going to click on the Advanced tab, and if this is grayed out and you can't change any of this, that's letting you know you got the serial number wrong. We need to go back and revisit that, but once you unlock it, this should be open like this and you should be able to make changes. So what we're working on is Auxiliary 2. We need to select the drop down box, and we need to find the WBjr, and in this case it's all the way to the bottom. We click on that. Now this doesn't really matter if it's set for off, on, or auto, but I like to set it for auto just so that I see this when I'm looking at the display or whatever the case may be. Once those two items are set, we click the little commit button to write it to the classic. That information was just written to the classic, and now we need to finish programming the WBjr. Here's something that does pertain to the WBjr, is this 25 degrees C. This allows us to, this is the neutral point, or the reference point for the battery temperature, if you will. When a battery goes below this number, the voltage that you're charging to will raise, and the capacity of the battery in amp hours will lower. And when the temperature of the battery goes above this number, the voltage we charge to will lower, and the capacity will actually raise. Now when I say the capacity will actually raise, that's not something you want to do on purpose, because higher temperatures damages the battery and it shortens its life, so keep that in mind. But this number is typically 25 degrees C by default. That's what it'll be. Most batteries require 25 degrees C, but a few manufacturers do want a different number, like 30 degrees C or whatever. So if you have to change that, you would use these up and down arrows, and then you could commit it over here. This number up here is to do with the voltage, so it doesn't really pertain to the WBjr, but this is the millivolts per degree C per cell that will compensate the voltage that we're targeting, because of this 25 degrees. In my case, my batteries are running about 10 degrees C, so it's going to elevate the voltage quite a bit because of that. And once those two parameters are set, you would click this button here to write those values to the classic. In my case, I'm not going to write that because it's already the same. Now, the next category down is the battery efficiency, amp hour capacity, and compensation percentage. And I do want to point out that the 25 degrees C right here and these three values here are all available from your battery manufacturers. If you really get stuck and don't know these, check on the internet, look at their spec sheets, give your battery manufacturer a call, whatever the case may be. But these values should all be available from them. Now, battery efficiency right here. What that is it's the efficiency of the battery. Typically, a battery state of charge meter will settle in at 94% by default. Some batteries are going to be higher than that. If you've got an AGM or a sealed battery, it might be higher than that. If the battery is new, it's going to be higher than that. I have found that on my particular bank of Trojan L16 REBs that they're about a year old, and I found that 93% efficiency gets me right about where I want to be. And what this is doing, what you're looking at here, is if you watch the state of charge as a controller goes through its absorb cycle, the state of charge should hit 100% just about exactly the same time the controller goes to float. If it's hitting 100%, say 30 minutes early, that means the efficiency number is probably too high and it's getting there too quick. Or if it's getting there too late, say it only gets to 90% when it goes to float, then this number may be too low. You may need to play with this number a little bit to tune that in. And this will change as the batteries age as well. You'll need to keep up with it and drop the percentage as the batteries age. The next one is capacity in amp hours, and what that is the amp hour capacity of the battery bank. So in my case, I have two strings of those Trojan L16 REBs, and they are 375 amp hours each, so I have 750 amp hours of battery. Now that should be right on the battery itself. It should be on the battery spec sheet, or you can contact the manufacturer for that amp hour capacity if you like. But that is something that does need to be set, and once that's set, you keep move on. And this one here is probably the more confusing one, and this is the percent per degree C compensation for the capacity. Basically what that means is at 25 degrees C, my battery bank has 750 amp hours capacity. But if my battery bank drops down to 15 degrees C, I'm going to lose 10% because I've got 1% per degree C. And that means that at 15 degrees C, my battery bank drops 75 amp hours. And that's not a permanent drop, it's just due to temperature. And that goes the other way as well. If the battery bank goes to 35 degrees C, then I gain 10% or 75 amp hours. So once you've got all three of those numbers set, this 1% is typically default. That is what most battery manufacturers want, but you can adjust it in 0.1% increments. So once you've got all those set, you would commit that stuff to the Classic by pushing the little right button over here on the right. And that would conclude programming all of the WBjr stuff. Now, there is something that you can do with ending amps, and some people like to use ending amps. And what ending amps is, it's a amperage at which, when it's in absorb and the charge rate falls below this amperage, the controller will automatically switch to float. The problem with that is that the controller doesn't know what's going into the battery. So if you set this number to say 6 amps and there's a 6 amp load in the house, you'll never get to 6 amps because the battery's taking some as well, and you'll just never be able to use end amps. But now we can actually use the WBjr to monitor the amps into the battery, and we can do true ending amps. So if you tick this little box over here that says use WBjr for ending amps, what happens is now the Classic watches the actual WBjr or the shunt, and when it sees it passing 6 amps into the battery or less, it will switch to float. So as the absorb cycle tapers on through through its time period, the amperage will drop off, and when it drops below 6 amps, it will initiate a float charge and terminate the absorb charge based on ending amps instead of the time. So it works for both. And again, that's just set the 6 amps. You can adjust that wherever you want. Tick the little box over here showing use the WBjr and click the little right button to write that value to the Classic. And now you're doing end amps and you've got your state of charge meter all set up. So now I want to click this little arrow up here, and then I want to go to status, and this is where we would read all of the WBjr information. As you can see here in this screen, we have system amps right here. Oh, that's telling me that my 3 charge controllers that are running right now are putting 21.4 amps into the battery bank to maintain the absorb charge, and I am down 37 amp hours. I'm negative 37 amp hours, and I have a remaining 750 amp hours, and my batteries are 100% state of charge. Now this number here is not compensated because, as you can see, I don't have a battery temperature sensor installed on this unit right now. This should be down about 75 amp hours in my case right now because of the temperature. And as you can see, we're almost to the point of switching to float. We got 37 more amp hours to go, and we're already at 100%. So again, that's everything right there. State of charge percentage, remaining amp hours, that's how many amp hours are left in the battery bank, and that is a temperature compensated number. So if my temperature sensor was plugged in, that would probably be down in the 650 range because I'm probably running about 10 degrees C on my batteries right now. and then net amp hours, and this will reset at, when it goes to float, or it doesn't have to. You can set it either way. And to set this, if you want this to reset every time it goes to float, we go into the config tab, we go to the tech tab, and let's see if we can find that right here. We would tick this little box that says reset net amp hours on 100% state of charge. And now when the controller goes to float, and that's what triggers 100% state of charge, by the way. We're going to assume that the controller is programmed correctly so that when it does switch from absorb to float, the batteries are truly 100% full. And with that in mind, when it does make that transition from absorb to float, it's going to reset this to 100%, and now that I've ticked that box, it's going to reset that to 0. That concludes setting up the classic light or a regular classic using the local app for the WBjr.